Hello everyone, I'm Tushar Pandit and I'm very excited to present this session today on creating an enterprise database cloud with Exadata Cloud Customer. In this session, I will give an overview of what Exadata Cloud Customer is and then focus on API-led automation capabilities in Exadata Cloud Customer. So let's first talk about the Oracle data management vision, which is essentially based on three main pillars. Number one, enabling the world's best converged database, supporting many different data types and data models like JSON, XML, graph, IoT, blockchain, text, as well as having the most robust and most mature low-code platform known as Apex. Number two, deployed on Exadata, cloud-scale database infrastructure with extremely smart system software that is all optimized for the Oracle database. And number three, the autonomous database cloud, self-driving, self-tuning, completely autonomous with embedded AI and machine learning technologies as part of the service. Now, as customers are moving to cloud, there are customers that have constraints to fully moving to public cloud. And those constraints that we have heard of are related to restrictions they may have on the regulatory front or corporate policies that require them to have the data on premises within their own data center. Or some customers may be a little bit risk averse, that they may have concerns about multi-tenancy, which means sharing their workloads with the same underlying infrastructure with other customers. Or they may have concerns related to response time, where they may have real-world systems that have very complex relationships between each other, and it requires low latency communication. And it's sometimes very hard to disentangle these systems from each other. And that is the core reason why we came up with this offering known as Exadata Cloud Customer. And the idea here is that it provides the best of both worlds, as it gives the same public cloud benefits, but now with the service running in the customer's data center. So as we say, if you can't get your database to public cloud, we will bring the cloud to you. So essentially what you get with the Exadata Cloud Customer is the best database cloud now running in the customer's data center with the same public cloud hardware, the software, the same user experience, the same APIs, as well as the same public cloud operational model, where Oracle manages, monitors the underlying Exadata Cloud Customer infrastructure so that the customer doesn't have to do that, as well as the same commercial model, the pay-as-you-go, subscription-based commercial model, so the customer only pays for the resources that they're using. So in this way, essentially what we are enabling is customer getting all the benefits of the public cloud, but the data still remains on premises, and it meets their requirements on regulatory front, on latency front, as well as any of their corporate policies. All right, so let's go a little bit deeper into the Exadata Cloud Customer architecture. And this diagram is essentially, it's a build-up diagram showing you how the systems are connected with the public cloud. So what you're seeing out there on the left is the Exadata Cloud Customer deployed in the customer's data center. And then the Exadata Cloud Customer is connected to the customer's corporate intranet for database access or access by the application servers for the databases that are running on Exadata Cloud Customer. Now, the Exadata Cloud Customer also has these local control plane servers, and these are connected to the Oracle public cloud, which is essentially where the control plane for the Exadata Cloud Customer runs. So when the customer first subscribes to this service, they essentially create an account, or what we call it as a customer tenancy. And what happens during the deployment time, when the Exadata Cloud Customer is getting installed, there is a connection made from these control plane servers. It's an outbound HTTPS TLS tunnel that is created to the public cloud region, which is the closest to the customer's data center. So you as a customer have the choice on picking up the OCI region, which is closest to the customer's data center. And this tunnel is used for two main reasons. One is essentially for all customer administrators actions. So for instance, the customer administrator is invoking the cloud UI or the REST APIs to do normal operations like database lifecycle calls or grid infrastructure lifecycle calls or VM lifecycle calls, creating the VM or increasing the OCPUs on the VM. All those API calls are going through this green line. They hit the OCI public cloud region, and they are then traversing this secure tunnel over to the local control plane service and get executed on the Exadata Cloud Customer infrastructure. The other place where this tunnel is used is for Oracle actions. So as I had mentioned, Oracle, remember, monitors and manages all the infrastructure components of Exadata Cloud Customer. What I mean by infrastructure components, it's everything, including the hypervisor and below. So the physical servers on which the database servers run on, the Exadata storage cells, the switches, all of these are monitored. And so all the telemetry information is going over this tunnel. The other place this tunnel is also used is for infrastructure maintenance. So Oracle will do in an automated manner quarterly infrastructure updates. And so those updates are also going through this tunnel. So this is kind of a little bit of a brief overview of what an Exadata Cloud Customer architecture looks like. Okay, so now let's look at a little bit of the customer adoption that we have with Exadata Cloud Customer. And this slide shows you some of the logos that we have, customer logos that we have on Exadata Cloud Customer. Today, we have hundreds of customers that are running in production, running their mission-critical database workloads on Exadata Cloud Customer. As you can see, some of the logos out here are marquee customers across the enterprise. Some of the biggest financial services companies like Deutsche Bank, some of the biggest semiconductor companies like Samsung or telcos like NTT, Higher Ed, Texas A&M or McMaster, and many other manufacturing and retail companies all running their mission-critical workloads on Exadata Cloud Customer. One customer that I want to talk a little bit more about is Deutsche Bank. We recently signed a partnership with Deutsche Bank. Deutsche Bank is one of the world's largest financial services company. And they selected Exadata Cloud Customer to do a massive digital transformation and modernize their bank's database technology. Deutsche Bank is going to be moving thousands of databases, in fact, more than 95% of its systems to Exadata Cloud Customer, supporting and scaling mission-critical applications and services like trading, payments processing, risk and capital planning, as well as regulatory reporting. And so there is the press release was something that I put out here. You can look into the details of the press release. I put a link out there. But just reading through the quote that has been put out there by Bernard Lukert, who's a Chief Technology, Data, and Innovation Officer at Deutsche Bank, that Exadata Cloud Customer will simplify and modernize our technology environment, save the bank significant costs, and reduce energy consumption through consolidated server. So yeah, we're very excited about this partnership with Deutsche Bank. Okay, so that was a bit of an overview of Exadata Cloud Customer. In the next part of this presentation, I will present the automation capabilities in Exadata Cloud Customer that can help database administrators automate their regular database administration tasks and essentially enable them to spend more time on doing more with data, on how to use data and doing data engineering tasks work to further enable their company business to further innovate on their business side. So so now what are the key capabilities required to flourish in this area of data engineering? And it's all about automation, automating routine database administration tasks, automating database infrastructure management, automating database availability, best practices around database availability, like the Oracle's maximum available architecture that we have today, or automating security configurations. And the idea here is that with this automation in place, administrators can then have more time to focusing on using that data, giving access to data, building data models to essentially drive new business initiatives, right? And so Oracle uniquely offers a choice of automation and deployment for our customers. So as you can see on this slide, starting from the left, of course, this is the on-premise Exadata that many customers use today. In the middle, we have Exadata Cloud Customer, on which this presentation is based on. And then on the extreme right, we have autonomous dedicated Exadata Cloud Customer. And then the level of automation, as this arrow shows, keeps on increasing as you go from left to right. And our focus is on this middle offering, which is Exadata Cloud Customer, and which gives you a lot of automation, deep and broad automation, at the same time giving you the ability to control and customize things like you have root access to the guest VM, so you have more control and more ability to customize things. All right, so let's take a look then what capabilities, cloud automation capabilities we have in Exadata Cloud Customer. So as this slide shows you, if you focus on this picture on the right, everything from the user interface to the CLI to SDKs, as well as DevOps capabilities like Terraform and Ansible, are essentially relying on the underlying OCI REST APIs. So as a developer or a data engineer or a database administrator, you could invoke any of these interfaces or even directly call the REST APIs. So from the Cloud UI perspective, a user would, or an administrator would use Cloud UI for doing one-time actions, right? And doing some sort of ad hoc tasks. And the UI makes things very easy, as we will show in the following slides. REST APIs, of course, you could do programmatic access via the HTTPS, and then essentially create automation using the APIs. The software development kits, we have lots of options with that, with Java SDK, Python, Go, Ruby. You could use that and integrate that with different applications that you're building. Or you could use CLI and extend the console's functionality. If you are used to scripting and you want to automate tasks through scripting, CLI is a great tool for doing that. And then, very popular DevOps capabilities like Terraform and Ansible allow you to essentially treat Exadata Cloud Customer as infrastructure as code. So a broad set of capabilities. Will go a little bit deeper into some of these areas. So let's first take a look at the OCI console, and let's go through some common database administration tasks. And the most common of them, of course, is creating an Oracle database. And you will see how simple it is to create an Oracle database with the extreme ease of use and agility. So if you have subscribed to the Exadata Cloud Customer service, you will, this is the console you have access to. You go into the Exadata Cloud Customer OCI console, and one of the screens out here is basically to create a database. So you click on creating the database, and then simple things, you just provide the name of the database, you select the database version, 19C, 18C, 12C, whatever you would want. You then select the database home which you want to create the database in. So you could either select an existing database home by clicking on this drop-down button, or you can create a new database home. In our case, we are selecting an existing database home. And then you would provide the database admin password. And then you would choose the database workload type, whether it's transaction processing or data warehouse. And that's pretty much it. You click on creating a database, and a database is created, right? So all the steps that we had, all of this is all automated and made extremely simple as part of the console. And then you see how we do it even with the CLI or the REST APIs. Let's take another common administrative task for managing database, which is doing updates or patching your database or patching your grid infrastructure. So in this case, what I'm showing you is a screenshot for updating your database home, and you want to say update your database home from version 19.3 to 19.5. And what Oracle does as part of the Exadata Cloud Customer service, we upload all the patches and all the updates either for, say, databases or for the grid infrastructure, or even the guest OSs. And so you can then basically use them. So in this case, you would go to the console, you see this link called View Patches, you click on that link, and you will see a list of updates. In our case, we want to use the 19.5 update. So we select that update, and then we click on the pre-check operation. And essentially what the pre-check operation does is it's checking for all the underlying dependencies that you may have. It checks for, hey, are all the configurations okay? If everything is healthy, then the pre-check passes. And essentially then after that point, the user can go ahead and apply the update. And that's pretty much it. The system, the cloud service, then patches the database home, and it's updated now to 19.5, as you can see on the screenshot. So all the manual steps that you were used to do traditionally in the past, in doing all of this or writing your own scripts to manage updates, is all being done out of the box. It's all automated and made available to you as part of the console, as well as REST APIs or CLI. Okay, now let's take a look at the OCI CLI and some of the DevOps automation capabilities that we have with Terraform to see how you can now programmatically manage this at scale. So OCI CLI, right? So when to use this? So as we talked about, if a developer or a data engineer wants to automate tasks through scripting programmatically, CLI is a great tool to do that. Very easy to use with Exadata Cloud Customer. You can follow the documentation that I mentioned here. That the link is out here, and you could install it on any of your preferred client, whether it's Mac OS or Windows or Linux. And if you look out here, the syntax is pretty intuitive syntax. Everything starts with the letter OCI, and then essentially you have the name of the service, the type of the resource, and then the action. Essentially the action that you want to do on the resource, and then you have options as the list of arguments that you may want to supply. So for example, in this command, we have the command says is OCI db home list. What essentially is saying, list all the database homes in this specific compartment that you have. And compartment ID essentially is your compartment Oracle Cloud identifier. Every resource in Oracle on OCI Cloud has an OSID associated with it, so you could identify it. So you will give the OSID of your compartment, and you will also give the OSID of your VM cluster in which the database homes are, and are the ones that you want to list. So in this case, in this particular command, DB is the service name, DB home is the resource type, list is the action, and options is the rest of the string, right? Again, advanced options supported for lots of different complex inputs, managing input and output all through the CLI commands, as well as a lot of very advanced filtering capabilities. So definitely recommend to look more at the product documentation to see what capabilities we have in the OCI CLI for Exadata Cloud Customer. Some few more examples on how to use the OCI CLI, and let's take a look at few of the common commands, right? So a few of the common commands that administrators may want to do is scaling up an Exadata Cloud Customer VM cluster. You as an administrator may realize, hey, I need to put some more horsepower on my databases. I need to add more OCPUs. And so you can essentially use this command called OCI db VM cluster update command. Again, it will take in the VM cluster OSID, as well as you are now specifying the CPU core count, and say you want to increase the OCPUs by 40. And you're saying wait, you're giving this another argument, wait for state available. So what is happening is this command will wait until the scaling operation completes and the VM cluster lifecycle state returns to available. Another example of using CLI, say, could be adding an SSH key to the ExaC C VM cluster. So again, in this case, you are using the same db VM cluster update command. you're passing the OCID of the VM cluster ID, and you are then passing the payload for the public keys, and that typically goes in a JSON file where you will define the public key. The third example would be creating a database on the Exadata Cloud Customer VM cluster. We saw how easy it was to do it on the UI, and you could do the same with the CLI, and then you could automate this tasks in a script. And so in this particular command, if you're using the DB database create command, you pass the admin password, the DB name, the DB version, whichever you would want, the DB home OCID, and then of course the VM cluster OCID, right? So all the things that you would want to do to specify to create a database. So again, very simple way, very intuitive way for you to use CLI to do your automation. Okay, so let's take a look at one other technology, which is Terraform. Terraform, as you probably know, is extensively used in the DevOps area, and we also have support for Terraform with Exadata Cloud Customer. And when to use this, you would basically use it to programmatically manage or version your Exadata Cloud Customer infrastructure when you're creating these resources. Helps you as you're managing your infrastructure across your DevOps teams. How to use with ExaC C? You essentially install first the OCI Terraform provider. OCI has its own Terraform provider, and there's detailed product documentation around it. And as you may know, Terraform code is written in this language called HCL, and it's a declarative language, right? And so your goal is to describe your infrastructure you want using this language, and then Terraform will figure out how to create the infrastructure or the resource. And so with this Terraform provider you use your own tenancy ID, OCID, your user OCID, and all the rest of the arguments that are given here. And then, as I mentioned, you would describe the Exadata Cloud Customer infrastructure in a Terraform configuration file using the HCL language. Now, here, OCI has got lots of good flexibility and capability here. There is a capability called OCI Resource Discovery, and this feature allows, when you use OCI Discovery, it basically discovers all the resources in the customer's compartment and creates the required Terraform configuration files. And so once you've created the Terraform configuration file, then it's pretty simple steps that you follow. You initialize Terraform. So it's basically the Terraform binaries are connecting with your specific configuration files. You run the Terraform plan. The plan allows you to actually see first and view and sanitize, hey, these are the things that I actually want to change. At that point, you can decide to drop certain things or add more things. And once you're happy with the plan, you apply the Terraform configuration, and then you can create the resources you want. So again, a very extensible way, very widely used way of managing infrastructure as a code. So here is an example of how you would use Terraform for Exadata Cloud Customer. In this case, you are creating an Exadata infrastructure, and this is a typical format on taking a resource command in Terraform. It starts with the provider name. In this case, OCI is the provider name, and underscore database Exadata infrastructure is basically the type of the resource that needs to be created. And then the next argument, test Exadata infrastructure, is essentially an identifier. And that identifier basically maps to this resource. So this identifier you can now call in rest of your Terraform code and manage it however you want to. And then the rest of the things that here are just arguments. You would specify those arguments. So in this case, the Exadata Cloud infrastructure, to create it, takes in multiple different IP addresses for the control plane, for the admin network, the nest mask, NTP server, and all those things that you would provide to create an Exadata infrastructure. You would have similar resource type to create a VM cluster or a VM cluster network. Okay, so those were some of the capabilities that I mentioned to do regular automation of your day-to-day automation. As we talked about, the underlying infrastructure completely monitored and managed by Oracle. So the administrators, database administrators, do not have to do that. And then we saw how you can automate the regular database, creating a database, or patching a database, patching a GI, or creating a VM cluster. All of these could be automated either through the console, through CLI, or through Terraform. So now I would also want to talk about is automation that we have enabled in more complex services like the availability as well as security areas, specifically in the area of automating our Oracle's maximum availability architecture. So let's take this is a screenshot of how we have automated Data Guard. So Data Guard is our key solution for providing disaster recovery in Exadata Cloud Customer, and which has been fully automated as part of our console, OCI REST APIs, and the CLI. So you could create the Data Guard associations, you could delete them, you could do, enable switchover, failover, reinstate. All the kinds of configuration steps are all very easily done through the console or through the REST APIs. You could set the protection mode. In this case, I'm showing maximum availability. You could have chosen maximum performance. Another area where we have done a lot of automation is around in the area of security. An innovative feature that we recently came out with is Oracle Operator Access Control feature. And this is more focused towards the regulated industries like banking and financial services or utilities, where customers may want more control when a human or operator from Oracle is trying to access the Exadata Cloud Customer infrastructure that is within their corporate data center. They would want more control over who is accessing the underlying infrastructure, limiting what they have access to, components that they can access, as well as what commands they are executing. It also enables customers to get full observability as well as recording of the Oracle operators commands and keystrokes that have been executing. The customers also have the flexibility to terminate an Oracle operator connection as per their discretion. So as you see out here on this slide, this is a screenshot of the Oracle Access Control feature. When you create this Oracle Operator Access Control feature, you have multiple choices. You can select the actions to pre-approve. So that means that if you say select infra full, that means an Oracle operator has access to all the infrastructure components. Or you may decide to choose just the hypervisor. In that case, the Oracle operator can only access the hypervisor to do any of the troubleshooting, and they don't have access to any other components on infrastructure components on Exadata Cloud Customer. As you can see, all of these capabilities, all of the granular capabilities we have as part of this feature completely baked into the console, made it very easy to use, also made it automated as part of our REST APIs and CLI. So in summary, 3 points I would like to highlight. Number one is that our Exadata Cloud Customer provides the world's best database cloud service, providing superior cloud agility, automation, and elasticity in the customer's data center. The customers get the same public cloud benefits, the same operational model, and the same financial model. Number two, deep and broad automation for all the cloud administration tasks. So it automates all the manual and tedious database administration tasks, so customers and administrators can focus more on doing higher value added activities. And we saw a broad set of automation capabilities with API, CLI, Terraform, and many more. And number three is full embedded automation for availability features like our maximum availability architecture features like Data Guard. We saw how easy it is to set up using the UI, and the same thing with the APIs, as well as innovative features on the security front, like the operator access control, is fully baked in as part of the console as well as the APIs. So in a nutshell, with all this automation in place, database administrators and data engineers or database administrators evolving into a data engineering role can spend more time on using the data, on building new data models to further innovate on their business. So to know more about Exadata Cloud Customer and our automation capabilities, please review our product documentation as well as connect your Oracle sales contact. Okay, so with that, it's a wrap from my side, and thank you for listening to this presentation.